This is for the notes on the math lab, and I wanted to take you guys through some of the examples that we're looking at so that we can talk about the shifts that are happening. So the first one here is going to be, we're going to want to graph these three functions, the sine of x, the sine of x plus 3, and the sine of x minus 2. And from there, we're going to describe what's happening. So I'm going to leave the description part up to you, and then I'll talk a little bit through some of the graphs. So the first thing that we have is sine of x. Now we went over this function specifically, so we're going to get that down real quick. Let me switch my pen to red. And we have sine of x. So sine of 0, that's going to be 0. And then sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. So I'm getting those values from the parent graph because sine of x is just the parent graph. And then we have sine of negative pi over 2, sine of negative pi, sine of negative 3 pi over 2, and sine of negative 2 pi. So let me just connect those as smoothly as possible. All right, and then we're going to want to get into these other two graphs, the sine of x plus 3 and the sine of x minus 2. So let me get the sine of x plus 3. And when you're doing this, if parentheses come up on a device that you're using, you're gonna want to put sine of x in parentheses and then do the plus 3. So I have Desmos here, and I want to do sine of x plus 3. And then a couple of things I want to do. The first thing is I'm going to want to match the table and everything as to the one that we have here. So from negative 2 pi to 2 pi. So let me put that in. So my x-axis is negative 2 pi to 2 pi. And my step, or the intervals that we're going, are pi over 2. So I'm going to put pi over 2 in for my intervals. All right, and then my y-axis is going from like negative 4 to positive 4. So let me put that in, and those are just going by ones. So negative 4 to positive 4, and we're just going by ones. Okay, so we see here, you could be talking about it right now, is that we're shifting that sine of x function up 3 times. So basically what I'm doing is my sine of x function everything got added 3. All the y values that we were at got added plus 3. So here was at 0, so now I'm moving it up 3 times. At pi over 2, it was at 1, so I'm moving that one up 3 times. And then we're going from there. So those are some key points that we have. And let me get this graphed in here. There we go. So you can see it's the exact same function, just shifted up 3 times. Now I'm going to want to do sine of x minus 2 in green. There we go. And back to Desmos. I'm going to leave sine of x plus 3 in there. So sine of x minus 2. You can see from that original function it got moved down twice. So right here, we were at 0 before, and now we're down to negative 2. So everything got shifted down by 2. So let me put that in here. Down 2, down 2, down 2. So there we go. So those are these vertical displacement transformations. What you're going to want to do is you're going to take the parent function, no matter what it is. And if you see something added or subtracted outside of that parentheses, you're going to want to take all those y values that you had. You're going to either want to move them up or you're going to want to move them down by those same values. So if we had something like cosine or tangent, you're going to take those specific y values and you're going to move them up or down based off of what you see. So moving on to the explore phase shift, we're going to want to take, I'm going to take us through graphing these three functions now. And then we'll talk about what's happening when you add or subtract things inside of that parentheses. So the first thing that we have is sine of x. And we want to do that in red real quick. So sine of x starts at 0. At pi over 2, it's at 1. At 3 pi over 4, it's at, sorry, not at 3 pi over 4. At pi, it's at 0. At 3 pi over 2, it's at -1, and so on and so forth. So notice how this scale is actually switching to pi over 4, so keep that in mind. All right, so there's my sine function. And what we're going to want to do is sine of x minus pi over 4, we're going to graph that in blue. So let's see what happens in Desmos. Actually, let me fix my window real quick. So in this one, we're going from -2 pi to 2 pi, but we are going by a scale of pi over 4s. And then our y-axis is -1 to +1. And I think that one's just going by ones. Let me double check that. Yeah, actually let me go from like -1.5 because that's what it kind of goes a little bit further and then we'll be good from there. So our first function that we have in blue is sine of x minus pi over 4. Okay, so from here we can see some important parts right here. So what's happening is it says minus pi over 4, and that original 0 point, the one that started at 0, 0, that one got shifted to the right, pi over 4. So you're gonna think about it like kind of doing everything opposite. So if it says minus pi over 4, all those x values get shifted to the right by pi over 4. So let's go ahead and graph that down. So everything got shifted to the right by pi over 4. Okay, now this one is going to get shifted to the right by pi over 4. This one to the right. This one to the right by pi over 4, so on and so forth. So there it is, everything got shifted to the right just a tiny bit, just by that pi over 4 value. So our next one that we're going to do in green, we're going to want to add pi over 2. So let's see what happens when we add pi over 2. So sine of x plus pi over 2. Okay, there we go. And what we notice here is that everything kind of got shifted to the left by pi over 2 values. So originally we were at 0, 0, and then it was kind of going up. So then that one got shifted to the left pi over 2 times. You might think, oh, okay, so I have this negative pi over 2 and this pi over 2 over here, so which way did it get shifted? But think about that sine function. That sine function is always increasing from 0, 0, so it goes up. So on here, we want to see also the path that's corresponding to going up. On pi over 2, it's decreasing, so that's not going to be the value that we're going to be looking at. We're looking at the shifting to the left by pi over 2, because that's the part that's increasing right there. So let's get those values. Everything got shifted to the left by pi over 2. This one got shifted to the left. This one got shifted to the left. This one got shifted to the left. There we go. So when you're adding or subtracting, you're kind of doing the opposite of the values when it's inside of the parentheses. So this is a little bit different than our last example because we are shifting up and down because it was outside of that parentheses. So let's move on to our next example. In this one, we're going to be looking at how things get reflected. So I'm going to start here with sine of x in red. So sine of 0, 0, sine of pi over 2 is 1, sine of pi, sine of 3 pi over 2, and sine of 2 pi. Kind of notice here how our scale has shifted back again. So we'll have to fix that in Desmos. Let me delete these two equations right here. And our scale has shifted by pi over 2 again. So there we go, looking at pi over 2. This time I'm going to put in sine of x real quick so we can take a look at that. Because our second function that we'll be looking at is negative sine of x. We're gonna graph that in blue and we're gonna look at what happens. So negative sine of x. And it kind of looks like a jumbled mess or some DNA if you're looking at kind of what that looks like. So when we're looking at this, you can look at all of the y values. All of my y values basically got flipped to that opposite side. So right here, I was at +1, but then that got flipped to -1 when I graphed negative sine of x. So you're gonna notice all the zeros didn't change because if you flip that to the negative, it's still 0. Over here, I was at -1 at 3π/2, but then when I have negative sine of x, it flips up to +1. So all of those y values are flipping. So let's see how that works out. So all the zeros were the same, but the y values got flipped to the opposite end. So that's what we're looking at when we're looking at reflection. When you have a negative value outside of the function, you're going to be flipping the y values. You're gonna have the opposite y values that you had with. So if we had a cosine or negative cosine of x, wherever the y value was, you're just flipping that to the negative end. We have a couple more examples to look at. So let's take a look at amplitude. So we have sine of x here, and it looks like my scale has been the same. So we were looking at before, we know that amplitude is half the distance from the maximum to the minimum. So just cut that in half. So if we remember here, the sine of x function, let me switch this to red. Sine of x had an amplitude of 1 because it went from -1 to +1. And so you're just cutting that in half because -1, +1 is 2. Cut that in half, that's just the value of 1. So if we're looking at this now, let me get these down. So sine of x I have, but our next one, oh wait. So I haven't graphed this yet. So let me graph sine of x real quick. There we go, that's a good sine of x function. All right, so let me change the y values to go from, we'll go from -2.5 to 2.5. There we go. And our first function that we're going to grab is 2 times sine of x. So let me put that in, 2 sine of x. What you can see here is that it kind of got like stretched out a little bit. All right, so let's see what happened. First, let's look at the amplitude right here. So the max value here is 2 and the minimum value is -2. So if we're looking at half of that distance, so the full distance is 4, but then if we cut that in half, we actually get it down to 2. So the amplitude is 2. And let me switch this to blue real quick. So the amplitude is 2. And let's go ahead and graph it. So one other thing to take a note of is all the zeros came out to be the exact same. So basically the y values got multiplied by 2, no matter where they were. So if here it was at 1, so I'm multiplying that by 2. Here is at -1, so I'm multiplying that by 2. -1 times 2 is gonna be -2. And we still had the exact same zeros. So on this third example that we're going to do in green, we have an amplitude of 1/2. So kind of similar to the last one, what we can notice is that the value that we're multiplying by is going to be the amplitude that we're getting. So let's take a look at that. 1/2 sine of x. And you can see everything got shrunk down basically by half. So over here, my maximum is 0.5 and my minimum is -0.5. So that distance between -0.5 and +0.5 is 1. We just cut that in half, we get 0.5 or 1/2. So let's go ahead and graph that. So all the original y values, we shrink down by half, but we still have all those same zeros as before. So this one's -1, shrink that down to half of that, and that's -0.5. So when we're looking at amplitude, you're actually taking the values, the y values, and you're multiplying the y values by the value that you're multiplying the function by. So if we had 2 cosine of x, whatever the y values were, you're gonna multiply those by 2. All right, so now we're looking at what happens when we're multiplying inside of that parentheses. And we're gonna talk about what's the period, what's happening to the period. If you recall, the period is going to be when we're looking at it from how long does it take to repeat the exact same stuff. All right, so how much does it take to get back to the 0 where we're increasing again? So at sine of x, let's graph sine of x, and notice here that our values have changed. So I'll put this in from -1 to +1, and then -0.5 to 2 pi. All right, I'm gonna leave sine of x in there. And we're going here from -0.5 to 2 pi. And are we going by pi over 2? No, we're going by pi over 4. There we go. So you can kind of, let me just move this over just a tad. All right, so we can kind of see that, of course, sine of x has not changed at all. Does my y-axis change? Yeah, let me fix my y-axis real quick. So -1.5 to +1.5. And I just do the 0.5s to get a little bit more space up there. All right, so let me graph sine of x real quick. All right, so we're looking at the period, and then we're looking at where does it go from 0 to increasing again. So I'm starting at 0, and then I'm at 2 pi I have another 0 where it looks like it's going up again. So that's going to be the part where I'm increasing again. So the period where that starts to repeat is 2 pi. It takes a length of 2 pi to repeat like that. I'm going to now graph sine of 2x, and we're going to look at what happens. Sine of 2x. Let's graph these down first. So I have the point 0, 0, pi over 4, 1, and pi over 2, 0. So let's graph those down. So 0, 0, pi over 4, 1, pi over 2, 0. And it looks like it's going to kind of be repeating from there. So if we're looking at where it's repeating, notice here, right here, I have a 0 where it's increasing, and then I get another 0 where it's increasing. So the period in this case where it starts to repeat again, you can actually see that we have this kind of hill and then valley where it's going across and gets repeated right next to it, right in this area. We can see that it starts to repeat, and so our period is where does it start to repeat? It repeats after pi. So our period is a length of pi. We have our third example that we'll do in green. And let's put this over here. And we're gonna take 1/2 of x. So sine of 1/2 x. And I need to actually expand this a little bit to go over to 4 pi. It's gonna look a little bit messy, but we'll be okay. All right, so let me get some of these values in, because at pi it's at 1, and then at 0 and 2 pi is at 0. So let's graph those down. So at 0 and 2 pi, and then at pi it's at 1. At 3 pi it's at -1, and at 4 pi it was at 0. So we can graph that out. So it's a little bit harder to do on the computer. So where we start to repeat in this case is going to be between 0 and 4 pi. So the length of the period is actually 4 pi. So let's take a kind of look at this real quick about what's happening in between these three cases. So in this first case, which is the original, so sine of x and cosine of x have a period of 2 pi. But when I multiply by a value greater than 1, so by 2 in this case, when I multiply by a value greater than 1, it kind of decreases that. So it kind of brings that in a little bit. So what's happening to the x values? So what's happening to the x values here is basically we're cutting them in half, or we're cutting them by the reciprocal of what we're originally cutting them by, what we're originally multiplying them by. So let's take this 0, or this pi over 2, 1 point in this case. So at pi over 2, and then I have 1. But if I take that pi over 2 and I multiply it by the reciprocal of 2, and remember the reciprocal, you just take 2 over 1 and you flip it, so now it's 1/2. So I'm taking pi over 2 and I'm multiplying it by 1/2. So let's write that out real quick. Pi over 2 times 1/2. And if you just multiply straight across right there, I get pi over 4. And that's where the new x value was. That new x value became pi over 4. And then you can still see that the y value never changed. I never changed the y value. I was affecting the x value when I was multiplying inside that parentheses. So let's look at the second case. You see here at pi over 2, I have 1 again, right? I'm looking again right there. So if I take that x value was pi over 2, and I multiply it by the reciprocal of this 1/2 right here. So 1/2, I flip that, that's 2 over 1. So I'm taking pi over 2, and I'm multiplying it by 2 over 1. Well, those 2's divide out, and I get pi. That becomes my new x value. That's why it's over here at pi, and then the y value, again, never changed. It's at pi, comma, 1. So that's what we're doing. We're multiplying by the reciprocal, and that's what you're gonna wanna keep in mind when you're multiplying inside of these trig functions. So I'm gonna leave this to you guys where you put it all together. A, B, the x minus h, and then the plus k. What do they all mean? How do they all affect the graphs? Because you're going to want to be at the point where you can graph all of this from memory. You want to have all of those parent functions in your mind about what they look like. The cosecant and the secant where they're looking like this. The tangent function where it kind of looks like hair. Sine and cosine are all of our sinusoids. They look very wiggly. And you're going to want to be able to stretch them, move them up and down, shift them left and right, take that amplitude, change the period, really pull it out, and you're gonna wanna be able to do that from memory. You're gonna wanna be able to look at a graph and tell me what that function is and how do you get that. You're gonna wanna be able to take all of those descriptions that we're doing and be able to put that down into a function. So that's your goal when you're going through this, and that's why we have all this practice in here. But really focus on getting that practice down. And if you need any help, I'm Mr. Hernandez, and I'm always here to help.